The project had three main focus areas around authentication, data curation, and then also scalability and large file support. And this 18-month project actually recently finished at the end of March. So if you'd like more information about that particular project in general, we actually recently posted a blog post about the project, and I invite you to look at that later. I think we'll be sharing the slides, so you'll have the link to that blog post directly. So data curation involves preparing data so that it's reproducible, reusable, discoverable, and accessible to others. So the development work for this tool was really inspired by this user story. So as a user, I want to add details about the variables in my data set after I've uploaded it to Dataverse. Dataverse is a repository to share research data. Initially, it was just sort of launched at Scholars Portal for OCL, but it's recently expanded, and we actually have 55 universities across Canada now subscribing to that platform. So the Data Curation Tool was developed as an external web application that connects to Dataverse that allows you to create and edit metadata at the variable level. And this is using the Data Documentation Initiative Standard, or DDI standard. And this development work was led by Victoria Lubitsch at Scholars Portal. So powerful statistical software like SPSS allows users to store variable level metadata. But the idea with this DCT, this would allow you to incorporate this kind of variable level metadata just within the browser. So that's really exciting for people who might not have access to, say, those larger statistical softwares or other kinds of packages like that. So the aim of this tool is really to improve data curation workflows and also to promote the adoption of standards and best practices as well. So to give you a little bit more idea about the motivation behind the tool, this is an example of a tabular file. The red circles are really showing you kind of unknown aspects that would be hard for someone if they came across this file without any accompanying documentation or a code book or anything like that. Difficult to be able to interpret and reuse it. So for example, there are no variable names, there are codes there, you don't know what the values mean. So this would make it really difficult for someone to be able to reuse it. So adding that variable level metadata would make the data set more reproducible, more reusable, more discoverable, and also accessible to others. So when would you use this data curation tool? So this is an example of a data curation workflow within Dataverse, just one of the ones that you can set up. So this would involve a researcher and then maybe a curator or Dataverse admin. So one use case would be for when a researcher uses Dataverse to upload files and get their data set ready. They could then use the tool after depositing their data before they would maybe submit this data set for review by a curator. So they could actually enhance the data and by enhancing the metadata at that point. So you can see that with the sort of red sign there. Another option would be for a curator or a Dataverse admin to use the tool as part of the review process. And this could likely be perhaps in consultation or coordination with the researcher or user who deposited the data set as well. So it could be used in multiple places along this curation workflow. So some more details about what this tool does. You are able to view summary statistics for individual variables. You can add labels for the variables, group the variables together, and even add weights as well. You can create and edit variable level metadata, which is kind of the name of the game for this tool. One major feature is that what happens after you've made these changes in the DCT is that this information is saved back to Dataverse, and then you can actually export it as a DDI XML file. So you can actually have that outside of the Dataverse application if you'd like. And another value add was that we created a DDI formatted HTML codebook. This is for the entire data set, but it also includes all the variable level metadata that you might be adding with this tool. Some other development details. So it works with tabular data files. These are file types like CSV files, SPSS, SAV files, and Excel files, things like that. these normally go through Dataverse's tabular ingest process. This is additional processing that results in, for example, a non-proprietary derivative tab file. So the application actually works with these types of files. The DCT application was built with Angular 7, and in terms of design components, it uses the Angular material theme. It also leverages Dataverse's APIs to be able to read and write data back and forth from Dataverse. And as part of this project, we also submitted code back to Dataverse to add API functionality for variable level metadata. So that was part of the development work. And Caitlin Newson at Scholars Portal actually conducted some user experience testing. This was on an initial version of the DCT. This was with 5 participants, but with varying kinds of background with data. And so we were able to have some really crucial feedback that we incorporated into the tool. And people just generally found it very easy to use. So that's really great. And all of the code can be found in the GitHub repo that you can see there. So I'm going to do a little demo now. And in the interest of time, I've actually just recorded myself using the DCT, and I'll just talk over it because sometimes with these live demos, you never know what's going to happen. So what we're starting here is a Dataverse dataset page. And I've already uploaded one of those tabular type files, and it's already gone through the tabular ingest process. So, oops, it's already going. That's really quick. I'll just start it again. Okay, so the first thing you see is that there's a configure button, and then that you can click and launch the Data Curation Tool. This will open in a new browser tab. At this point, you'll see this is the actual tool. It has the name of the file, the citation. You can see a list of the variables. You'll see at the top here that we can actually search for specific variables. You can actually sort the variables based on these names at the top. The pagination is over here as well. And I'll show you some other features now. So you can actually toggle between English and French, which is a really important feature. If you click on the eye, this allows you to view the summary statistics for that variable. If you'd like to create a group, it's really easy. You just name the group. You go back to all variables. You can select them and then select add to group, which adds them to that group. It's really easy to deselect as well. You just click on the deselect button if you'd like to remove them from the group. So if you go over to the pencil icon, this is where you're able to add and edit variable level metadata. So for example, adding the literal question for that survey question, add notes. You'll see here also, if you want to add them to other groups that you've created, you can also do that here. There's also the ability to add a weight if that's what you'd like to do, or even indicate that this particular variable is a weight. That's a really great feature too. You click update, and then what you're able to do is then download this as that XML file, or you can save it back to Dataverse as well. So once you've saved it back to Dataverse, there's a couple of things you can do. You need to publish the data set, but you can also download that XML variable metadata file. And you can also export that codebook. If you go to the metadata tab here and then export, you'll see this new option for DDI HTML codebook. This is a really great sort of value add that you can save alongside the data set too if you'd like. I'll just note that all the variable level metadata will show up in there, and the changes that you make will be incorporated into that HTML codebook. I also wanted to mention under the versions tab, you can also see who has made the changes using the DCT. So you can see here that I've been the contributor and I've changed some variable level metadata using the DCT, so it tracks those sort of provenance versions as well. Yes, so that's our quick demo of the tool. And I have some screenshots here just in case. There we go. So the next thing I just invite you to do really is to try out the tool. It's available in our production Dataverse, which is our normal Dataverse. And all you need to do is just upload one of those tabular files, and then you'd be able to launch the DCT. You can also try it out in our demo Dataverse as well. This is a great place just to try things in general, so I invite you to go there first, actually. And we also have more information on the GitHub repo as well. There's some documentation there and some screenshots and things like that. Just a note about some future developments. So we always like to kind of keep up to date with the tools and make sure that we're responding to the needs of the community as well. So we've already heard some feedback, and some of that includes improving the group feature that I showed you. So the ability to be able to have subgroups is one thing that people mentioned. The ability to reorder those groups, and then also view which variables have already been added to groups. So we're looking into how to incorporate that. We're also looking into how to incorporate the variable metadata within the main Dataverse search as part of the Solar Index. So that would mean that search results would reflect this variable level metadata, which would be really great. So we're also investigating the metadata elements and fields that we can incorporate and include. So you can see that there were a few fields there, but it'd be great to be able to expand on that and maybe include some other, this very sort of social science focus. So it'd be great to be able to broaden that a little bit. One community member mentioned that there's some issues with the document description section of the DDI codebook. So we'd like to improve the accuracy of that metadata too. That involves incorporating and sort of working with the Harvard Dataverse, the larger community as well. We're also looking at how we would be able to incorporate this content from the Data Curation Tool in our Data Explorer tool, which is another modular application that allows you to look at tabular data files as well. So having more kind of connections between those two platforms, and some other tweaks to the look and feel of the application, so improving things like multi-select for variables and other kinds of things like that. So some things on the horizon. So if you'd like to learn more, we have a blog post called Introducing the Data Curation Tool. It's a great place to start. We have, again, some basic documentation in GitHub, and we have another webinar that we did for OCL. It's open to anybody to view. That's a little bit of a longer kind of introduction to it and a longer demo as well. So I invite you to watch that if you're interested. We're always happy to hear comments and questions and feedback. So if you have anything after the webinar today, please feel free to contact us at the email there. And we really would love to hear from the community. So I really encourage you to let us know how you found using the DCT. So thanks very much.
Thank you, Megan. So next up, we'll have Alex.
Yeah, hello folks. We are going to talk about Radiam. Just give me 1 second to get my screen share kicked over here. All right, I think that looks good. So welcome. This is a presentation on Radiam, which was a Canary-funded project that ran through most of last year. It was a collaboration between USask, most of the current Further team, as well as SFU, which is me. I am Research Data Management Systems Librarian, and 2 developers we hired for the project, Yang Zhou and Jonathan Lowen. So what is Radiam? That's a very good first question to ask. Radiam is both a platform and a suite of apps we've made for working with that platform that work together to catalog research data. And this is a bit of a mouthful. The basic impetus behind Radiam was we are pretty happy with the job we did on Further as far as depositing and storing data over the long term. But of course, if you work in RDM, you frequently get researchers coming to you saying, what do I do for active storage? How can I best make use of your tools before my data set is complete and ready for publication? And that group is certainly more underserved. Historically, they've been a more difficult group to serve because they have a broader array of domain tools they use, and we don't want to be too prescriptive. So with Radiam, we did our best to make something that was fairly generic, but would scale up adequately and would work across a number of disciplines. We allow configurable rich metadata entry. Again, it's nice to have web forms like that outside of an actual deposit process. And we can help you then export your metadata in preparation for publishing. So here is a fairly scary looking architecture diagram. On the left-hand side, you'll see a number of different data sources that you might want Radiam to index. You might have a server or a desktop workstation, a big data repository, HPC cluster like Compute Canada server. Here, you'll see the actual code we wrote on our indexing agents. They all will then talk to our Radiam API standard that we developed. They will be fed into a metadata index, which is basically the Radiam server platform. None of the files themselves or their full text have to be copied at any point of this. We basically wrote a Dropbox-style local indexer that will still do the work of indexing files down to a single index without having to look at their contents or copy the files themselves. So it respects privacy, but it also lets you maintain a single unified index of files across a number of different data sources in a lab or some other context like that. And then we've got different access levels, people who can access it, data managers who can create those forms and templates, and you can package it up all at the end publication in a repository like Furter. Here is a much simpler diagram. You'll see you've got some research data located on, say, a desktop workstation. You run the Radiam indexing client. It pulls metadata. That metadata gets fed into our main index, and multiple other clients can do likewise. You can then query that index from the browser, or you can review it as a project manager. Our technology stack is a lot of really nice modern stuff that I'm pretty fond of. We use Django, the Python web stack, to build out our API and a lot of our web backend. We use React JavaScript for the front end, Postgres for a database, Elasticsearch for indexing, a lot of good modern stuff. This tool helped me bring up my skill set on desktop development using Electron, which I'll talk about in a second. And it was just in general, a great project to work on. I'm very, very happy with the stack we were able to use here. And having a discrete Canary funded project is really good for something like that, because we often get stuck maintaining existing code bases, and this was just all around solid in that department. So progress update. This is basically the state of the art at the end of the Canary funding. So our API specification is pretty much complete. You can log into Radiam, you can view projects, manage metadata, and so on. I'll demo that at the end of this slide deck very, very quickly. We maintain desktop clients for Windows, Mac, and Linux, both GUI and command line. That was most of what I worked on with my colleague Guangzhou. And we have portal integration. So if you're already using OSF or Hub0 to do this sort of aggregation work of tracking a number of different files from different sources, we can link into your OSF or your Hub0 account, and we can also mirror your file list to Radiam, and you can get some basic metadata properties that way as well. Here is what our web interface looks like. You can see a summary of files. You can see where they were indexed from. You can see their file size, their last index time. On the left-hand side, you can see a React menu with a bunch of different other properties you can browse around. You can look at all of your data sets, all your projects, all your users, and so on. And here is a more in-depth view of file metadata. So you can see where a file was indexed from. In this case, this looks like it was indexed by Todd, and it was running on one of his Mac Minis. So this is coming from a desktop rather than from a server. We really help you pick and mix your data from all the different sources it might live on. You can see the file path, when it was last indexed, and some basic keywords. We do have functionality to parse out rich file metadata if you want to. So for example, if you're using a bunch of netcdf files, or a bunch of Office documents, or a bunch of PDFs that all have like common EXIF metadata, Radiam does support extracting that and then letting you sort on it. We are not currently doing that by default because there might be some privacy issues there, but the client is configurable to allow you to do that if you want to. You can opt into it. We also have relatively nice geographical metadata. So you can annotate any given data set using Leaflet in your browser. So if you decide that you want to say that these data pertain to this area, you can sketch a polygon in a map interface. You can do a bunch of drawing, and you can say, okay, here is my new geographical metadata. And I think this serializes down to GeoJSON. Here is a form that doesn't really excite anybody, but I think a lot of the librarians can appreciate how valuable it is to have like a proper GUI for configuring a metadata field against an existing schema. In this case, this is built against DataSite. And this is one of those things that we'd like to see in all of our applications, but still often only exists in backends. So you can configure metadata fields against a schema and determine which of them are required for your data set, which you want to use for your project, and so on and so forth. So that's a good bit of UI work right there. And I think we would actually love to talk about getting this into more projects in the future too, just as a general community piece. Here is the backend Django API. Again, this is really, really robust. I like what Django let us do. Any way you want to interact with Radiam in the backend, you can. If you're happy just using our clients, that's fine too. The clients all use the API calls directly. Here's the agent. This is most of what I worked on, like I said. So we've got Windows, Mac, and Linux clients that you can download. They use Electron and Python together. It's a nice combo for doing desktop development. And they will run in the background, index files in your machine, act just like Dropbox. They don't use too much CPU in the background because I'm super anal about that. And I'm really happy with how those came out. You've got a full code base on usask.rc/Radiam on GitHub. It's divided up into the main server chunk of the code where everything posts to, as well as the agents live somewhere separately. But it's all on GitHub. It is MIT licensed, so very open source. We are hoping to be able to continue developing it. The Canary project is done. We've got a base of users right now, but a lot of this work I would love to see make its way into other projects and keep being used as a feeder for some of our existing repository platforms. So really keen to keep talking about that. And just credit the original project members. The PI was Kevin Schneider at USask. The co-PI was Dugan here at SFU. Project lead, Jason Halati from USask. That's in common with the Furter team. And then, as I said, USask, SFU collaboration, Lee from Portage provided supervision, and a lot of the existing Furter personnel, with thanks additionally to Rama Periasamy and Justin Pointer, who were unique to this project as well. I am going to jump out of this presentation super duper quickly and just show off some additional web presence for Radiam, if you can still see that. We've got all of our documentation published on Read the Docs, so anything you want to see about deployment or the agent, you can see some more nice screenshots of what that agent looks like. It runs in your tray on Windows or Mac. It was pretty cool building a background tray app like that, and I think it makes it look pretty elegant. Of course, I'm showing off the part I worked on. I can log into one of our demo instances. I'm not going to show off too much here because I've already done the whole slideshow, but you can see here's a demo instance. You can look at some existing projects. You can do a brief search in some dummy data, and you'll see that a search for water is bringing back different results from different machines. So again, you can have lots of different clients dialed into Radiam, and you can see where they're all providing data from and which data. We've got all of our release code on GitHub for download. Here is just an internal OSF instance. If you wanted to hook in an OSF, this is like the file list that we have in our internal OSF at SFU Research Data Management. And all these files will then get mirrored and cross-indexed in Radiam if you wanted. And then Hub0, if you don't know with it, is a different CMS app that has some traction in Compute Canada. And we are also able to mirror content from Hub0 to Radiam. So that's it.
Thanks, Alex. And next up we have Tim. Tim, you can share your screen now.
Okay, cool. Hi, everybody. Let's go. Okay, so yes, I I want to talk about DataSeer. So we've got this tagline, getting beyond the guidelines, and hopefully it'll become clear what I mean by that in a moment. So there's 4 problems I want to start off with. I'm sure most librarians are painfully aware of these. Most articles are published without their underlying data. If an article does share its data sets, it probably only shares a portion of them. And sometimes the data sets are in either proprietary formats, or they've shared a table, but they've actually shared a picture of the table. So there's absolutely no way of getting the data out of that table. And the problem is that metadata about the shared data are inadequate. So there's often no way to find out who deposited it, when it was deposited, what the associated article was, and so on and so on. And citing data sets is also very patchy. That is when authors reuse a published data set or a public data set. Sometimes they cite the article, sometimes they don't cite anything, sometimes they cite the data set, which is actually what we want them to be doing. And that makes it really hard for anyone to work out how much data sets are being reused. And this is something we need to do a lot better as part of building data sets infrastructure, to give people credit for what they're doing and to make it easy for them to see when people are reusing the data they've produced. And so these are how we as a community have responded to each of these problems. So first, our response to most articles being published without their underlying data is a policy, and this is the joint data archiving policy, which I was involved with formulating. Journal requires as a condition for publication that the data supporting the results in the paper should be archived in an appropriate public archive. That is, to publish in this journal, you have to share your data. So there's the policy. Next, for data sets, shared data sets being incomplete and in useless formats, here is some guidance from PLOS. And this is there's a lot of information on the PLOS website. For example, authors should submit the following data. This is an explanation to authors what of their data sets they need to share. Values behind the means, values used to put graphs, point extraction from analyses, and so on. And then our response to datasets being in the wrong format. Here's part of a large table on the Oregon State website where it describes the different types of data that people have produced and the different formats that those tables should be in for being shared publicly. And similarly, here's another library guide. This is the metadata that should be a library guide for the metadata that should be included with the data set, the rights, subject, date, creator, identifier, and title. And that's the sort of bare minimum. There's actually another table in Squeeze On, which has all the sort of desirable information in it too. And lastly, in response to citing data sets being very patchy, you can find all sorts of information in libraries and elsewhere about how to cite data. I just put up here the Joint Declaration of Data Citation Principles, which sort of organize and sits behind a lot of this work to say what we should be doing as part of data citation. So these are a big list of principles, and it's had a lot of impact on educating people on how to cite data, but whether or not it's actually changed practice is an open question. So certainly this is the first step. So the unifying theme here is that the policies and guidelines I've just shown you are all very generally worded. They say, okay, you should try and include the numbers behind your means. You should try and include this. And all these different guidelines appear in diverse locations. Some are on the library, some are at the journal, some are maybe at the institution level, and some are at the funder level. So when researchers come to the point of having a finished article, or even earlier in the process, they have to go and search out and integrate all these sources of information about how they should be sharing their data. And that is hard work. And unfortunately, it's sufficiently hard for them to work out what they should be doing that they often don't. And they are time limited, and so they just throw their hands up and get on with something else. And data sharing just falls by the wayside. At the same time, because it's hard for anybody to work out what authors should be doing for a particular manuscript, nobody can enforce the policies. They can't go and say, well, you should have done this, this, and this, and you haven't. nobody's really sure what should have been done. And so it's very hard to go to the researcher and say, you didn't do it, because they don't know what should have been done. Okay. So the solution here is to get specific, to tell authors exactly what they need to do right now for this particular document, the document they've just finished. You need to take the following steps. And this eliminates the need to locate and interpret multiple guidelines and policies. And also, because you're meeting authors where they are at their document, there's going to be less inconsistency in which set of rules or set of policies are being applied. So DataSeer uses this approach to tackle all 4 of the problems that I described at the beginning. So what we do is we use natural language processing to read scientific articles, and we find the sentences that describe data collection. The machine learning categorizes sentences as either being a data collection sentence or not a data collection sentence. If it is a data collection sentence, it then works out what type of data is being collected. And in terms of machine learning tasks, this is actually not that hard. So here, from the methods of a manuscript, is a sentence where the authors say, we compiled global data set for carbon and helium isotopic composition. So that is a clue to the machine learning that data set has been collected. And again, for a psychology article, section 3.1, we collected data from 122 undergraduates. So we collected data is a strong clue that data was collected. And likewise here for an article in molecular ecology, this is the top line is showing sampling information. Owls were sampled by collaborators. And then further down there is reflectance spectra data being collected with a very specific tool, an ocean optic USB spectrophotometer. So every time you see the word spectrophotometer, you know that spectrophotometry data is being collected. And likewise, for down in the bottom right there, we can see from all these clues, 22 polymorphic microsatellites, this is microsatellite genetic data being collected by the authors. So method sections of articles contain characteristic sentences where the authors are collecting data. And then what DataSeer does is it uses, when it's worked out the type of data and found these data sentences, it gives the best practice sharing advice for that data set. And it also recommends a repository where the data will go. So for this article here, the sampling information should be shared as a sampling table, which is a subtype of a tabular data. And the sample tables must contain detailed information about exactly when and where each sample was obtained. The columns indicate any subgroup samples belong to. So this is crucial information a sample table should contain. And then it gives more general information about what tabular data should look like. And then it says what the most suitable repositories are. This bottom section here is a bit unsatisfying at the moment, but is going to get a lot better because we're going to hook up with DataSite and we're going to have an active API bringing across dataset recommendations that are dynamically changed depending on the authors, the journal the authors have submitted to, the funder, the institution, and the type of data. So it's going to have very context-dependent recommendations for different repositories. The reflectance spectra data are also best shared as tabular data, and the microsatellite data are kind of genetic data, and it gives specific advice about what to do with that. So the original data output, in this case, is actually also best shared as tabular data, but the sequence output file should also be shared as well, so people can assess the quality of the microsatellite data. And also, I want to show you this because I was talking about data citation. This is a case where the authors have collected, have brought together previously collected data, and DataSeer can spot these cases of dataset reuse and prompt them to do the right things to help people locate this instance of dataset reuse and to work out what exact datasets the authors have used. So it gives them advice here. For public datasets, provide the DOI or stable identifier and include a citation for the dataset in the reference list. Be sure to indicate exactly which data have been reused. In many cases, it's best achieved by sharing the code used to extract the part of the data that you analyzed. And so this is what DataSeer looks like in practice. I'm going to stop sharing for a second and share a different screen with you all. Oh yeah, sorry, I should have thrown into the information I gave to Melanie. One of my sole claims to fame in data sharing is I had an article about data sharing covered in Vanity Fair a few years back, which was quite the thing. It's actually a really funny article as well. Anyway, so DataSeer, this is what it looks like. So here is the methods section of an article. In fact, it's an article of mine. If we click on this first data set here, it's spotted that it's tabular data and that it's a sample table, and it's given me the advice that I just showed you. And in response to this advice, I can then tell it what I have done with this data. So I give it the name, this is the sampling data, and I provide a DOI for where I've shared it, which is on this Dryad repository here. And there's this next sentence here, which it spotted, captured fish, which is again a valid data collection sentence. However, it also belongs, it's actually exactly the same data set as this. And so what I'm going to do is delete this as a data set. And then I'm going to link this data set with this first one here. So this sentence is now part of that data collection. This here is not the same data set. In fact, it's us collecting surface temperature and salinity. And so this is just, again, tabular data, no subtype. And here is the advice for sharing tabular data. So now I've put in temperature and salinity data, and this is also available on Dryad. But further down, I've collected morphological data, so the marine and stream individuals. And again, there's this sentence here, which was measured. So that is a valid data sentence, but unfortunately it's part of this one. So I'm going to delete that one. DataSeer is still learning. We've put in about 3,000 articles worth of data sentences, but it's going to need tens of thousands before it gets really accurate at spotting what is a data sentence, what's not a data sentence, what's a data sentence that's part of an initial, that should be associated with a different paragraph. And so lastly, to go down here, there is some sequence data it's spotted, and I didn't actually share this data, and I should have done. So this is DataSeer spotting something I should have done, but didn't do. And then lastly, there is additional genetic data on single nucleotide polymorphisms. Okay, so that is what DataSeer looks like. And now that we've finished, we can click finish here, and it takes me through to a page which shows what I've done. I can reopen it and go back and change some things, but it showed me what data sets I've collected. It also suggests a data availability statement that I can put into my article. And it shows, can also show the data curator what data sets I deleted. If there are genuine data sets in here, the curator could maybe ask the authors why those data sets were deleted and not shared. Okay, stop sharing and go back to PowerPoint and say thanks to Kristen Rattan at Stratos, who's been with us all along, Daniel Lernberg at UC Curation Center, Jason Roberts Origin, and Josh Greenberg at the Sloan Foundation for providing funding. Okay, and that is that.
Thank you very much. Okay, so we're going to move on to the Q&A section of the webinar. So if you do have questions, please feel free to add them into using the Q&A tool in Zoom. We're going to go over some of the questions. You may have noticed these if you've been following along in the question box. Just a clarifying question to start us off. I just wanted to make sure from Kathy here that researchers, an example, data depositors can access the DCT themselves, no special permissions required. Megan?
Yes, so the DCT can be used by people who have the permission level at admin or curator for a data set. So if you wanted to try it out, the demo Dataverse, which I have the link in the slides from my presentation, it's a great place to try it out. And if you have any other questions or want to learn more about that, just feel free to email us as well.
Thanks, Megan. So the next question, what tool do you recommend for looking at XML codebooks? They look very messy when I open them up in my browser. Alex?
Yeah, sure thing. To be honest, I don't know if this was a me question, but I answered it because like an XML reading has been a bugbear of mine for years. We always talk like XML is great, and you open it and you're like, I hate this. Oxygen is the commercial desktop app that is still pretty widely used by like XML specialists if you have to look at XML by hand. I don't know how many folks really actually have like an Oxygen requiring use case. If you've got a nice text editor like Sublime or Atom, you should be able to do a pretty nice like table of contents view in the sidebar and expand and collapse your XML file as needed. So I would recommend a nice text editor. But it's also just not that often that you really have to look at a whole XML file top to bottom. So I would consider your use case. And if you have access to Oxygen locally, that would be the best tool.
Megan, do you have anything to add?
I'd just say that the sort of like what outputted from Dataverse for this DDI XML codebook, it looks pretty good from my perspective just in the browser. So I'd just be curious to see what it's looking like for other people. But yeah, I think what Alex suggested sounds good to me too.
Thanks. So a question about Radiam. Who are the intended users for this tool? What about security if extracting metadata from people's files? What about the data? Should a user be concerned about hacking? Yeah,
those are a bunch of good questions. So our intended users are really existing research groups of labs, or labs rather, of about 5 to 50 people. So like labs that are relatively large, but also down to like decent sized small project teams. Anyone who's got a lot of data needs a way to manage it, but doesn't want to use an existing cloud service for either cost or privacy reasons. As for the metadata extraction, that is optional, like I said. Compute Canada and Django both have very good security track records. I don't think there's any like high-risk breaches that I'm aware of in the recent past. So in general, I think we've got a pretty trustworthy stack here. It's not always encrypted at rest. That's what I'm working on in a different project right now, but I would trust it with up to medium risk projects. And even for human subjects data, if you're not indexing metadata and you're not indexing full text contents, I would use it in good faith.
Thanks, Alex. Our next question, apart from DDI, can Radiam map to other metadata schemas?
It sure can. My demo was actually with DataSite. I may have misspoken and said DDI.
Thanks. So our next question, who is the intended to use DataSeer? Researcher, journal editor, institutional deposit administrator? Tim?
Yes, is the answer. All of those use cases are possible. We are currently, our sort of initial use case at the moment is a journal workflow or a portal pre-submission to a journal so that an author can get a sort of a stamp on the article. Yes, all the data sets associated with this article have been shared. However, researchers can run the article through DataSeer at whatever point that they choose to. Institutional deposits can certainly, or even funding agencies can run a bulk of manuscripts through a bulk file of manuscripts and get a report. Well, we intend this functionality to be there, and it's fairly close. You can upload articles in bulk and get a report back on all the data sets associated with those articles, and then perhaps ask researchers to go along and find and share any that haven't been shared. Yes, so there are a wide range of use cases. In fact, one other use case that we are aware of and have put on the back burner is on the grey literature, because there are many different organizations producing a large amount of scientific-like reports, and those all have data associated with them too. And so this could be a tool to help these organizations manage the data associated with their reporting information. For DataSeer, the proposed date for launch is very soon. Well, it's going to be a sort of soft beta launch that people can upload articles and try it out. and we're beginning integrations with journals hopefully fairly soon. Melanie answered that one.
Yes, so our final question, what manuscript file types does DataSeer work with? Do you upload them to a website, specifically the file types?
Yeah, so it's on a website that can be not very easily accessed at the moment, but it will become much easier to get to. So it really just works on PDFs at the moment. You can upload, very soon you'll be able to upload a docx, and that will also display within the system. It also works with the XML produced by a wide range of publishers. They will have their own bespoke XML codings. We will expect to be able to comment on, we'll be able to incorporate most other sort of structured languages like LaTeX and so on without too much trouble. It's based on a system called Grobid, which our developer also develops, and that is a tool for ingesting documents and turning them into XML. And so that is being used by a lot of organizations and is quite flexible.
We do have a follow-up question in the chat. Can DataSeer recommend on 3D file types?
I'm not quite sure what that means. Is that it?
Kathleen, would you like to clarify? I've given you permission to speak, Kathleen, so you can clarify your question if you'd like.
Okay, if you're scanning using a 3D imager tool, like say, I don't know, it doesn't matter, you'll develop .ply files, you'll generate .obj files. There's a number of different, some of the files are proprietary, but you can then export them to work with, you know, if you want to upload it to, I can't remember the names of the services, but if you want to use MeshLab, or you want, you know, you're going to be dealing with a variety of different kind of file types that you can import and manipulate or then export. Usually it's a .ply, or there's some JPEG files and maybe in association with .obj files.
Yes. So we have a wiki that I could perhaps show people briefly. Here that we have built, which contains the recommendations. And part of what we hope to do is, as people use DataSeer and they discover that DataSeer doesn't have the type of, doesn't talk about the type of data that they particularly have, and they want a new data type to be added, that can be put into the wiki. They can include specific advice for that, sharing that file type, such as 3D, and then we can then retrain the algorithm to spot that type of data and give future users specific advice on that type of data. We've got about 100 different types of data in here at the moment. This is what we went through, 3,000 different articles, and these are the data sets that we found. I should say, or the different types of data that we found. These, we have a slightly circular definition of data type, which is we count something as a specific type of data if it needs its own particular sharing instructions. And so that means that tabular data, which is by far and away the most common type of data, is the same advice, whether it's for tabular data from physics or tabular data from sociology. It's the same kind of data. So it will expand and become more available through time, more able to deal with lots of different data types in time.
Thanks. And a couple of follow-up questions about DataSeer. So a question about whether or not it is open access, and if you have journals committed to implementing it into their publishing process.
Yes, the code for DataSeer is open source. We haven't yet released the training data. That's something we're thinking about and working on at the moment. We would like to. We just need to make sure that this application isn't then spirited away by somebody, one of the large publishers. For DataSeer, we have journals committed to implementing it in their publishing process. There is one user at the moment, and they're using it sort of fairly informally and giving us feedback. And there is another publisher who we're having, a much bigger publisher we're having very serious discussions with. So it's getting close.
Great, thank you. And I believe a couple of other questions that have come in, I'm just going to check on that I know have been answered in text, but I just want to make sure that they're shared with the wider webinar audience. So a question from Shahira: is the Radiam team planning to create any video demos or other training tools to promote the platform and showcase its uses? Alex?
Yes, this is a very good question. I appreciate Shahira asking it. Canary projects are really hard to transition to sustainable service models. If you look at the list of Canary Pass funded projects, they are a lot of one-offs. So it's quite difficult to keep supporting something like that. Right now, we are doing our absolute best to advocate for Radiam. It lives in the further team. It's got a few users currently, like I said, and these opportunities are very helpful because this is being recorded, and I encourage someone to circulate this video afterwards. But we would love more opportunities to talk about it. So if you've got something in mind locally at UVic, I'm all ears, certainly.
Thank you. So we have answered all of our open questions at this point. If you do have an additional question, feel free to add that to the chat or to the Q&A feature. We do have a few more minutes. Oh, one just came in. Could DataSeer be a way of helping the tri-agencies to follow if data are shared after a grant project is finished?
Absolutely. This is one of our use cases. Something organization like the Wellcome Trust, which for years has had a very strict data sharing policy, in that you can't have any more welcome money if you don't share all the data. But it's very hard for them to know whether the researchers have in fact shared all their data. And so being able to put the articles that a researcher uploads as part of a new grant request through DataSeer to see whether all the shared data are available would be a powerful tool for them. And so if the tri-agencies go that direction, then yes, absolutely too. And what's more is the tool could also then be passed back to the authors to say, okay, you shared 4 data sets, but our analysis says that there are 10 here. Could you please go through, share all those, put them in the correct locations, and when it's done, pass it back to us and we'll check it. And that would help researchers ensure that all the data have been shared before they get given more money.
Thanks. Any other questions from the audience as we're wrapping up here? We do have about 1 minute left, so if there are any additional questions, we can try to get one more in. Seems like we're done with the questions for today. I do want to thank Megan, Alex, and Tim for presenting today. We will be circulating the recording of this webinar in addition to the slides. So if you have questions for our presenters today, I'm sure that they would be happy to hear from you. Thank you everyone for attending our webinar today. Have a wonderful afternoon.